In this video, we're going to continue looking at data transformations. So previously, we talked about how visualizations are an important tool for describing data, but unfortunately, it's rare that you get the data in exactly the right format. And this is also true for most analyses that we do. Almost always the first step is to go through and wrangle the variables or make some transformations that we need. And so we're going to continue looking at different packages that can help us with that. And in this video, we're going to start by looking at what is called the dplyr, and so that's how you pronounce that, dplyr package. And again, this is another one of those packages which are part of the tidyverse. And remember that packages in the tidyverse, they're packages that share a common philosophy of data and our programming, and they're designed to work together naturally. And so some of the ones we've seen before, we've seen the ggplot2, so we've seen a couple of these already. So as always, the first thing I want to do is run library tidyverse. And just remember that the first time you use tidyverse, whether it be on a new computer or if you update your R, you will need to install the package first. But the package is already installed on my computer, so I don't have to do that step. And so often when we read in a package, so in this case tidyverse, remember that it's going to give us those conflict messages, and so notice that dplyr overwrites some of the functions in base R. And we can see that right here under the conflict section. So for example, dplyr has its own filter function, and that's going to mask the filter from stats, which is part of the base packages or functions that are included in R. And dplyr also has another function called lag, which also masks. And remember that we've seen masking in the past, and that's just because sometimes different packages will use functions with the same name, and so there has to be basically one of those that R recognizes, or it can only recognize one of those at a time. So right now, if we were to call filter or the lag function, it would be the filter or the lag function from dplyr. All right, so let's look at some data that we can use. We're going to use the car seat data, and remember this is part of the ISLR library. And so again, for this particular package, I've already installed it previously, but if I hadn't, I would have to run the install.packages. I'm going to call forward the car seats data, and then I'm going to read about it. And so remember, this is a simulated data set containing sales of child car seats at 400 different stores. We have several different variables for this data set. And then we could also view the car seats data. And so here is that data set. We have the different variables up top, and again, by using that question mark previously, we could read about what each of those actually represent. All right, so let's look at dplyr. So remember, and this should say this week and last, we looked at five functions. There was filter, arrange, select, mutate, and summarize. They all work in a similar way. And so for each of these, the first argument is a data frame, and subsequent arguments describe what to do with the data frame using the variable, and the results in a new data frame. So the first thing we're going to do is we're going to check for some missing values. And one way we could do that is to combine two different functions together. We have the is.na function, and we have the sum function. The is.na function, what that's going to do is for each of the, we could think of them as spots, or each of the elements in a vector, it's going to go through and determine are they in A or are they not in A. And remember that NA is used to denote missing values. And then it's going to say yes or no for each of these, and then it's going to sum them up, and the no's are stored as 0 and the yeses are stored as 1. So if we sum over those, we're going to get the number of missing values. And so just so you can see what this looks like, if I run the first function by itself, notice I get a whole bunch of falses. So everywhere there's a false, that means it was not in A or not missing, and everywhere there would be a true, that would mean there was a missing value. And then summing over those, we see it was 0. So for the price variable in car seat, there are no missing values. And I could find the mean price of the car seats, and we've seen code like this before. And so notice that the price underscore mean 2 is stored as 115.795. All right. So next thing we're going to do is we're going to use the summarize function. So the summarize function, we're going to start out with the name of the data set, and then we're going to define a new object called price underscore mean, and we're going to set it equal to the mean of the variable price. Now notice when I use the summarize function, I don't want to have car seat $ price, I just want to have price by itself. And I want to have nar.rm equals true. Remember, that's always a good thing to have in your mean function, because if there were missing values, then we wouldn't be able to compute the mean. So if I run this, notice we get the exact same mean that we had before. But what we could do is we could assign this to be its own little data set. Now it ends up that summarize by itself is not terribly useful. As you could see, I could have just as easily used the mean function and gotten this exact same information. The summarize function is useful when we pair it by the group by function. And so let's see why this could be useful. So for example, we might want to find the mean price for different shelf locations. And so remember that one of the variables in our data set was shelf location, which was a factor with levels bad, good, and medium, indicating the quality of the shelving location for the car seat at each site. So here I'm going to set by shelf equal to, and I'm going to have group by the car seats data set and the variable that I want to group by. So let's see what this looks like. So I'm going to run this. And notice I get this new data set called by shelf, and by shelf has 400 observations of 11 variables, so the same as the car seats data set. And so if we look at it at first, it doesn't look terribly different, but we do have these extra pieces down here at the bottom. So we can double click on by shelf, and again, it doesn't look terribly different than what we had before, but let's see what happens when we pair this new data set with the summarize function. So here I have the same line of code that I did above, except instead of, skipped a line, I've got the summarize function here. Notice it's the same as what I have up here, but the only difference is I've now called the by shelf data set instead of the car seats data set. And I didn't have the na.rm equals true because there were no missing values, but I could go ahead and add that in. It won't hurt anything. So now let's run this. And notice what's now produced are the means of price for each of the shelf locations. So the by group function, what it does, or probably the group by function, is it allows us to take a categorical variable in our data set and then perform a function for each of the levels of that categorical variable. So again, here we're able to find the mean of price for each of those shelf locations. And so it's kind of hard to see that when we just look at the by shelf and the car seats, but notice that the by shelf has this extra set of attributes, and that's what's allowing this to happen, whereas the car seat data set does not have that. So here's another example. Here I'm going to create another data set called by shelf 2. And this one, what I'm going to do is not only group by shelf location, but I'm also going to group by whether or not the store was located in the United States or not. So in the group by function, we have the name of our original data set, we have the shelf location variable, and we have the variable that tells us whether or not the store is located in the US. And so again, notice I have a new data set here. It still has 400 observations and 11 variables, but you'll notice, again, there's a new set of attributes that go along with this data set. So now if I call the summarize function, and this time I'm going to call the by shelf 2 data set, and I'm still going to calculate mean price and find the mean of price. And again, just for completeness, I am going to add in that na.rm equals true. So now if I run this, notice I get the mean price for shelf location and by whether or not the store was in the US. So here I'm able to calculate the mean for price based on two categorical variables and all the possible combinations for those two categorical variables. So this is a really useful way that I can find summary statistics, again, based on different categories. And it could be one category, two categories. I could even put a third categorical variable in there if I wanted to. So another thing that's really useful when you're working with these functions is something that is called a pipe operator. And what a pipe operator does is it allows us to combine multiple operations. So suppose that we wanted to explore the relationship between sales and the average price spent on advertising. And so we're going to work through one potential workflow, and then we're going to see how we can use what's called a pipe operator to help us. So the first thing that I could do is I could group car seats by types of advertising. So let's remind ourselves what the advertising looks like. So advertising is the local advertising budget for company at each location in thousands of dollars. So let's just first get a look at what this advertising variable looks like. All right, so in thousands of dollars, we can see that we had one location that spent $29,000. We had 144 locations that spent no money at all. We had 10 locations that spent $9,000 and so on. So what we could do is create a new data set called by ad budget. And what we're going to do is we're going to group the car seats data set by advertising. So let's see what that looks like. So we run this and then notice we have a new data set up here that's called by ad budget. Again, still 400 observations of 11 variables, but now what it's going to do is it's going to have a separate group for each of these potential budgets. Now, step 2, what I might want to do is use summarize to compute the number of car seats, average sales, and average price. So one thing that's nice about summarize is up here in this example, I only use summarize to compute one value. We can actually use summarize to calculate multiple values at once. And so here, what I'm going to do is I'm going to call the by ad budget data set that we just created up here, and I'm going to compute 3 different values for each of those amounts spent on advertising. I'm going to compute the count, so how many were in each of those groups. So for example, once I get the output from this, I hope to see that the count is equal to 19 for the group that spent $5,000, and the count's equal to 1 for the group that spent $29,000. Also for each of those groups, I'm going to find the mean sales and the mean price. So let's run that. Now before, when I would run this and I'd run the summarize function, I would just print the output down here. This time I've assigned it to be sales data, and notice we have yet another new data set here. And so let's just see what sales data looks like. So here's sales data. So what we have here is for each level of advertising, so you'll notice that these advertising numbers, they line up with the amount spent on advertising here. The count is how many different locations or different stores spent each of these advertising amounts. So for example, what we saw before, where there were 144 stores that spent $0, and that's the same thing that we have here. There was one store that spent $29,000, and we see that down here. Sales and price, what this is going to be is for these 144 stores, this is the average sales and the average price. For those that spent $10,000, there were 25 stores, and this is the average sales and the average price. And so this data set is really a table that summarizes count, sales, and price for each of the levels of advertising. Now, step 3 is maybe I want to remove the low count. And so in the car seats data set, instead of saying car seats data instead of having car seats here, let's put low count stores or low count number of stores. So for example, going back to my sales data here, maybe I want to remove all these rows where there weren't that many stores that spent that much on advertising. So for example, maybe I want to remove that 29,000 and the 26,000. So here, what I'm going to do is now use the filter function and create a new data set called sales data 2. And what I'm going to do is I'm going to filter this so that it only contains those stores that have a count greater than 10. So here we have my sales data 2, and I can click on it. So now notice we only have those with a count that's greater than 10. Now the amounts going across here haven't changed. So for example, of those that spent no money on advertising, I still have 144, and their sales average is still 6.82, and the price average is still 113.56. And if we move over to the original sales data, we see that those are exactly the same. And then finally, maybe what I want to do here is I now want to create a plot where I look at that sales data 2 data set, where I want to make a scatter plot of the price times the sales, and notice this is going to be average price and average sales, and place a smooth line over it. And so here's what this looks like. And so again, if we go to our sales data 2, notice that we had 13 observations in this data set. We have 13 different points here, and each of these points represent numerous stores. So for example, the largest point that we see here, that's representing those stores that spent $0 on advertising. And then if we look here, we can see that this corresponds with the price of 113 and then sales of 6.82. So what a plot like this is letting us do is it's really allowing us to compare three different variables. We're looking at the overall trend of sales and price, and that we see as the price increases, the overall amount of sales tends to decrease, which makes sense. But then the third variable we have is based on the size of the points, and so that we can actually see whether or not there's any kind of trend in terms of maybe we would see that those with the lowest count had the smallest sales. I don't really see a trend here, but that's something that you could look for. So you're really comparing three different variables. So in this example, just to kind of recap what we just did, is we started out with our full data set that had all of the stores on it. But what we wanted to do is we really wanted to look at those stores based on how much they spent in advertising. So we took that big data set and we created a smaller data set where it was grouped by amount spent on advertising, and we looked at three different variables. We looked at count, average sales, and average price. And then from there we filtered out those where the number of stores represented was less than or 10 or less, and then we created a plot about it. So with the code above, we had to create a bunch of intermediary data sets. And so what a pipe operator does is it gives us a better way to create that code. It's more compact. And at first, it's going to look kind of strange, but once you get used to it, these pipe operators let us write code that almost reads like a sentence. And so what a pipe operator is that is this piece right here. So you'll see I've got one pipe operator, two pipe operator, and then three pipe operators. If we go up here to the top, notice that I've really had three different steps. And what a pipe operator allows me to do is combine those three different steps. And a pipe operator reads like the word then. And so I'm going to read in a sentence what this code is going to sound like. So I'm going to create a new data set called sales data 3. I'm going to start out with the car seats data set. Then I'm going to group that data set by the advertising variable. Then I'm going to summarize that data set by calculating for each level of advertising the count, the average sales price, the average sales, and the average price. Then I'm going to filter out those advertising budgets which had a count of more than 10. Or I should say, I'm only going to keep those that have a count of 10. I'm going to filter out those that have a count of 10 or less. And so this code right here is doing the exact same thing as all of this code. And one of the big benefits is we don't have to calculate these intermediary data steps. Now, to show you that we end up with the same thing, I've set this equal to sales data 3. And so if I run this, you'll see that sales data 3 is here. And now I'm going to make that exact same plot, except calling sales data 3. And you'll see you get the exact same plot. And so again, you can read this as a series of imperative statements. And so a good way to pronounce the pipe operator when you're reading code is then. And so you're going to practice next week how to actually do that. And I'll have you put in the word then when you see a pipe operator and show how that reads like a sentence. And so another example is this one right here. So notice we've used 3 different pipe operators again. And so for this one, I'm going to set my data set equal to poor sales. And how I'm going to create this data set is I'm going to start with the full car seats data set. I am then going to group by the 2 locations, urban and US. I'm then going to use the filter to rank sales descending, and I only want to keep those that are less than or equal to 3. I'm then going to arrange the data set by US and urban. So let's run this. Go through that one more time just with a little more detail. So again, we're going to create a data set called poor sales. We start with the car seats data set. So this is our full data set. We're then going to group by urban and US. So remember that urban takes the values yes and no, and so does the US, yes and no. Then what the filter is going to do is it's going to first, we've got 2 functions here. We're going to order sales by descending, and then we're going to rank them. So rank, the one that takes rank 1, since this is in descending order, is going to have the highest rank, and then the one with the lowest sales, or in other words, the worst member, is going to have rank 1. And so we only want those ranks that are less than or 3. So this is going to give me the 3 worst for each of my groups. And then I'm going to arrange that by first US and then urban. So again, going over to our new data set. Let's start with our US and urban. So remember that US and urban can take the values yes and no. So if we look here, notice for no, no, we have 3 values. And so there's your 3 worst sales. And then we have yes and no. And we've got 3 of those, and these are the 3 worst sales for yes and no. Then we have no yes, and the 3 worst sales for no yes. And then finally we have yes, yes. And then there we've got the 3 worst sales for the yes and yes. So take a moment. It might take a couple times to go through these to see what the different pieces are doing. But again, these pipe operators are really nice because they give us a way to read the functions, to read them almost like a sentence. So as always, if you have any questions, please let me know. Remember that you can't break anything in R, so the more things you try, the easier you're going to find this in the future. So please do play around with these different things. Again, you can't break anything. As you come up with questions, please let me know. I'm more than happy to answer those.